So today, I'm going to be giving an overview of the judge's scorecard. I just recently took over this job for Kim Wagenbach, who couldn't be here today because she retired last Friday. So those of you who know Kim, she's having a retirement party down about 3 blocks down the road at this particular point in time. She'll be there until about 5:30 today. So let's go on to the next slide. Okay, so just a little bit of an overview on how the judge's scorecard is going to be used. The purpose of this scorecard is to support each of the foreground tournaments, and the scorecard's been tailored for each of those 4 tournaments. And the judges themselves will be getting assistance from both Ames and Wallup's mission design centers. When they receive the data from each of the teams, that data will be sent to these centers so they can run independent analysis based on the data submitted. Next slide. So this is just a quick overview of what will happen. At the top, the teams will basically submit their data packages to our judges. The judges will then get support from the mission design centers shown on the left, and from SLS partners shown on the right. That includes SLS Payload Integration Manager, Safety and Mission Assurance, and their safety panel. Once the judges have a chance to get the evaluations from the mission design centers and SLS folks, they'll do their scoring. Now, if they find the data is incomplete, say for example, they can't, say if the mission design center cannot run the trajectories for some reason, or they have some questions with what was submitted, they'll send the questions back to the teams requesting additional information so they can rerun the simulations. At that point, the data will be turned over to the Centennial Program Office, where they'll make their final decisions for the awards for each grand tournament. So next slide. So basically, the scorecard will create a nice level playing field. It'll allow each team to have a very clear idea of what they need to provide to the judges for each ground tournament. And it'll give everybody a pretty clear idea of what's expected of them. So next slide. As I already mentioned, we'll have subject matter experts for both comm, orbital mechanics, systems engineering from various NASA centers supporting the judges in this effort. And for example, say for the design centers, you'll see they're going to be looking for, say, a standard data file and a SPICE file for running these data simulations for the orbital trajectories. Next slide. So I think Jim's covered this to some degree. Probability of mission success is going to be broken down into several categories: comm, orbit, or distance, longevity. We pretty much covered this, so I'm not going to go into that much detail. And I'll talk a little bit more in detail about what's going to be expected for the second half for SLS. Let's go on to the next slide. So when you look at this, I have an example at the very end of this presentation as far as what type of data is going to be required. You're going to see required data and optional data. And the whole purpose behind this is, since we know these teams have very, very limited resources, we didn't want to burden the teams with standard NASA processes across the board. Or what's required is what's really just essential to get you to fly. However, saying that, you will be judged by how much additional material you're able to provide to the judges to show that you have a robust design. So, for example, just because it says optional, if you only do the required data, your chances of winning are not going to be nearly as great as somebody who has been able to give a more complete picture. Again, though, by keeping it optional, it allows the team to decide on their own how you want to distribute your own internal resources to accomplish your project. So let's see. I think that covers that. So let's go on to the next slide. Yeah, I think we've already covered this. Next slide. Yeah, there we go. Yes, so as we go through each grand challenge, you're going to see everything's going to get a little bit harder from each challenge. So, and the judges are going to get more stringent as they review the data at each particular grand challenge. So let's get to the next slide. So this is a good breakdown of what to expect for each of the four events. For the first one, the NASA equivalent for GT1 would be like a systems requirements review. Basically, being able to define what your requirements are, what your interfaces are, what your overall mission design concept looks like. By the time you get to GT2, this would be the equivalent of a preliminary design review in NASA terms. We've tried to avoid the use of our normal structured terms because, again, when you see this, in a NASA PDR, a lot of items that are listed as optional would be required, so we didn't want to confuse folks by using our using our own internal nomenclature. But you could draw parallels to this. GT3 would be equivalent to a critical design review, and GT4 would be similar to a launch readiness review. And as you see, by the time you get to GT4, there are you're going to see a number of required metrics that you do have to meet since you're going to be interfacing with SLS. So let's go to the next slide. So this is a more detailed schedule to what we showed you before. It shows some of the more critical documentation and milestones that you'll be expected to meet for each of the stages. At the very bottom, you can see each of the four grand tournaments by date, and you can then look up and see the corresponding documentation that's going to be expected. So let's go to the next slide. So here, this is an example of two tabs on the spreadsheet. So you all have access to the spreadsheet. I strongly recommend you thumb through each of the tabs at the base and experiment to see what's there. If you see at the very bottom here, this is an example of some of the technical interface requirements you'd be expected to meet. So as you can see for GT1 and 2, most of the material is optional, but by the time you get to GT3 and 4, you can see how more and more of this material is going to be required. And then you'll see up here we've got like multiple set of tabs: scorecard, verification matrix. Across here, then we've got 4 of our input categories. One is input for comm, orbit, and unfortunately I cannot read that. We've got systems engineering over here, longevity. Yeah, and then you'll see over here the tabs keep on picking up down below. So with that, are there any questions? Lots of questions.
Where do you see the split from going from paper to mixed mode testing to you folks actually touching hardware, or do you envision not getting there with flavor is?
That's a good question. I think you'd probably see it, if you had to draw parallels to NASA, you'd probably start seeing it by GT3. I mean, any thoughts, Jim? There are no hard metrics, though.
There's no requirements that are hardware, unless there are NASA judges, or the judges aspects of the hardware or witness aspects of tests that the teams plan to conduct. But those will be determined by the judges for the purpose of validating or authenticating the information provided by the teams for the ground tournament. So there's not hard and fast rules about when or if the judges would want to actually put their eyes on the hardware, but it'll be determined on a case-by-case basis, depending on what information the judges want to authenticate or provide the basis of authentication.
Yes.
Yeah, so the ground tournaments are a physical tournament. You mail in your data and you review it, and if you have
Correct.
questions, you ask for.
Correct. Yes.
In cases where competitors have significant costs, as the plan absorb, would crowdfunding be an option? Like, as an example, after the competition is over, packages of data can be given away to members, donated to.
That's a good question. Do you want to field that, Jim?
Yeah, so the technical data is the intellectual property of the respective teams to do with as they wish. And crowdsourcing would be a great idea, corporate sponsorship, all these are possibilities for developing the resources needed in order to develop your payload.
Yes.
From what I've heard, what I see in the spreadsheet, it seems like this is almost totally technical. Are you factoring in at all at this stage of the game on these ETs, an evaluation of the resources behind these teams and whether they have the wherewithal to actually finish what they're doing?
I think to some degree, when we see the data and the designs, we don't have any hard and fast requirements to see what your portfolio, funding portfolio looks like. But I think you're going to, as you get into the details of each one of these items, you're going to see that you're going to have to be producing a certain amount of design effort. And I think it'll start to become evident as you get into the details for each of the items such as comm, orbital mechanics, the trajectory. Yes, Jim?
I'd like to add to his answer to your question. The reviews are technical, and they will be an assessment of the maturity of the technical products and the data that you see on the judge's scorecard are to be used as measures of likelihood of success technically. So there's not a programmatic review per se. There's nothing massive judges won't. I keep saying massive judges. So far only one judge is NASA. The challenge judges will not be assessing the wherewithal of the teams to be successful financially because that's not the purview of the challenge. It's not an objective of the challenge. So it would be a technical assessment. However, that said, there is a requirement that the teams document the resources that they expended, both in terms of human resources and material, for the purpose of the Centennial Challenge Program metrics that we're keeping. But that's different than any assessment about your likelihood to make it to the finish line because you have the financial wherewithal to do it. There's no assessment like that. So different maybe than, say, a NASA design review where programmatics are a factor. In this case, they're not. Another way of looking at it is teams are proceeding at their own risk. Teams are, free to make their own design decisions and free to make their own choices about where to emphasize their resources or where to scramble, cut corners, or choose that balance between risk management versus resource allocation. So but that's up to the team. Since if you think about it, teams are proceeding on their own, at their own risk. Prizes are only paid once the achievements are made.
And
So that's a good point, since it's not a contract, it's not a grant. We're not gonna levy NASA 7120.5 on you. This is, which is the programmatic aspects. You as competent technical people very well understand that there is usually a progression for how you successfully execute a project. So, please.
I think think just to build on that, by the time you get to GT4, if for some reason you're financially not able to meet the obligations for flight, then you proceed. This is why we have alternates selected. And I think we're out of time. So,
Thanks a
that's
lot.
it. Thanks.